Hello class, we're about to start section 12R 3.2 and in the tradition of the class I'm going to use the purple ink. So we will scroll down here. First of all, I want you to look at this website here. This website is very helpful. If you have any further questions with this lesson aside from asking questions of me, you could go to this website and it does break everything down step by step for you. Okay, now we have number one. It says mass for mass. Given an amount of mass per tablet, how many tablets do you require? Example, Metoprolol Lopressor, 25 milligrams PO is ordered. Metoprolol is available as 50 milligram tablets. How many tablets would the nurse administer? Okay, so first of all, we have 25 milligrams. I assume this PO is for per order, I guess. So it'll be 25 milligrams divided by 50 milligrams. And when we divide this would give us 0.5 tablets. So basically it'd be half a tablet. Okay, now scroll to number 2. Oh, one other thing. Just to show this, you notice they have the same units, so these units would simplify out. So that's how come we don't see milligrams here. So it'd be 0.5 per tablet. Okay, number 2. We have the mass and liquid for liquid. Given an amount of mass per liquid, how much liquid is required? Example. Well, I'll just say this. Some of these words I'm not even going to try and pronounce. Just say you see it on the screen, you can read it. So I'm just say this P word and this D word here is 0.1 grams. I'm assuming this PO is per order. Is ordered to be given through a nasogastric tube. P is available as 30 milligrams per 5 milliliters. How much liquid would the nurse administer? So we will have 0.1 grams, and we will multiply. Now we need to change this grams to milligrams. Now we know it takes 1,000 milligrams to equal 1 gram. So this would change grams to milligrams. We could put this over 1. Then we will multiply this. Remember, this is 30 milligrams over 5 milligrams. So this will also be multiplied by 1 over 30 milligrams. And that will be multiplied by 5 milliliters. Now, of course, we know we are doing division like we did here. So we would take this value and divide it by 30 over 5, which we know we would have to take the reciprocal. That's how come the 5 milliliters is now in the numerator and the 30 is in the denominator. So now we cross simplify. The grams and grams will simplify. Milligrams and milligrams will simplify out. And then we can multiply. 0.1 times 1,000 times 1 times 5 milliliters. It'll be all over 30. So that would give us 16.7 milliliters once you type it in your calculator. Are there any questions?
Wouldn't that be over 30? Or is it?
No, that's after we multiplied everything out. Because if we multiply this out, this will actually be 500 over 30. So if we took 500 divided by 30, that would give us this here. So this is an approximation. So I should actually put the approximation symbol here. Now, does anyone need me to show, just for clarification, how come the 30 milligrams is in the denominator and the 5 milliliters is in the numerator? If you need me to show it to you, I'll show it to you right now.
Yes.
Okay. Okay, this is what I'll do. For those of you that understand this, you can just pause the video. But for those of you that need me to show this, I'm about to show it. So I'm going to erase all of this. And we know we use this first portion here in order to get the milligrams. So we would divide that by the 30 milligrams over 5 milliliters, just like we divided these milligrams up here, right? So we know we will multiply this first, and this will give us 100 milligrams all over 1. And then we would change division to multiplication, and we would take the reciprocal, which is 5 milliliters over 30 milligrams. So this is how we ended up with that in the denominator and the numerator. So the milligrams will simplify out, and then this will give us 500 milliliters over 30, which will give us approximately 16.7 milliliters, which is basically the same thing we had before. Okay, now, all of this right here you can read at your leisure. And then we come to problem number 3. Now we have the amount in IV fluid. Now, it says, given the volume of IV fluid and the dosage expressed in percent, what is the mass? What is the mass of a particular dosage? Assume dosage is in grams unless otherwise noted. Example, calculate the amount of dextrose in 1,000 milliliters of D5W. Okay, so now, I'm going to go over this step by step. We will have our concentration, which is a percentage, divided by 100. And we will multiply that by the volume, which is our milliliters, which is equal to Y, which is our dosage amount. And then this would be given to us in grams. So it's our dosage amount in grams. This right here, this is a Y. Sorry. And remember, this isn't ing, this is in grams. Maybe I ought to separate that a little bit, so you'll know that it's in, and I'll write the G over here. So it's in grams. Okay, now, this is very important, especially if you plan on working in the medical field. If I need an IV from you, I want to make sure you all know what dosage to put in there, because that could be very detrimental. Okay, so we have the concentration percent. The concentration percent here will be this 5. So it'll be 5% over 100. And then that'll be multiplied by, we have 1,000 milliliters. And we can put that over 1. So when we multiply everything out, this will end up giving us 50 grams. And this will be our final answer. Are there any questions?
So how does the milliliters cancel out?
Well, actually it tells you here, whatever answer you get from multiplying this out is automatically in grams. Okay. All right, so now it says here, number 4. It says we have the IV milliliter rate. Given a certain amount of liquid in a time period, what is the necessary IV flow rate in milliliters per hour? Note that this is the measurement used when the IV is regulated electronically by infusion pump. Example, infusing 250 milliliters over the next 120 minutes by infusion pump requires what rate? So, we will have the basic formula, which would be the volume in milliliters divided by the time, And time would be in hours. And that equals to Y, which is the flow rate, in milliliters per hour. Okay, so now, this is what we would do. We're given that this is in 120 minutes. But remember, our final answer must be in hours. So we're going to have to change those minutes to hours. So we would start off with 250 milliliters divided by 120 minutes. So now we have to get rid of those minutes and make them into hours. So we will have 60 minutes is equal to 1 hour. So when we simplify, these minutes will simplify out. So now we have 250 times 60, or you know what, we could do cross simplifying. 60 goes into 60 once, 60 goes into 120 twice. So we had 250 milliliters all over 2 hours. Now when we simplify this, this will give us 125 milliliters per hour. Are there any questions on number 4? Okay, number 5. We have volume and time. It says, given a certain amount of liquid, a time period, and a drop factor, GTTS by milliliters, what is the necessary IV flow rate in GTTS per minute? Note that this is the measurement used when the IV is regulated manually. It is not possible to give a patient a fraction of a drop, so it is typical to round answers for these problems up or down to the nearest whole number. So now we have our example. Calculate the IV flow rate for 1200 milliliters of NS to be infused in 6 hours. The infusion set is calibrated for a drop factor of 15 GTTS divided by milliliters. So we will have this basic setup. We will have the volume, which is in milliliters, divided by the time. And this time the time is in minutes, multiplied by the drop factor, I'm going to put it in parentheses under here. This will be measured in GTTS/milliliters. And then this will equal to Y, which is the flow rate, in GTTS divided by milliliters. So this is the basic formula. Now we want to substitute in for the values. We had 1200 milliliters divided by, we were given 6 hours. We know we have to change those hours to minutes. So it's 1 hour for 60 minutes. And then we will multiply it by the 15. Well, actually, this is what I want to do. Instead of having the slash ml, I would have it divided by 1 ml. So that's the same as slash ml. So now we would simplify out the milliliters. The hours will simplify out. And this would give us 50 GTTS per milliliter after you multiply it out. Are there any questions on problem number 5? Yes.
It's supposed to be GTS minutes.
Oh, yes, I'm sorry. Yes, it's supposed to be minutes. Thank you. All right, that's supposed to be minutes. All right, thank you. Now, I could take the liberty and speak like my other colleagues say. I was just trying to make sure you was paying attention.